All right, here is the 4.1 homework assignment. There's a couple tricky problems in here, so I wanted to make sure that I took some time to talk you through them and let you know what's going on. So this prompt here, this one's actually pretty nice. The prompt, they tell you that x represents the full height of a certain species of trees. Fine. Assume that x has a normal probability distribution with mu equals 235 and sigma equals 91.2. What's going on here is the height of one individual tree is normal. The parent distribution is normal. That's what they're telling you in the problem here. And they're telling you that the center of the parent distribution, mu, is 235, and the spread for the parent distribution, sigma, is 91.2. And then none of the questions are about the parent distribution. All this information is about the parent distribution, but none of the questions are. The questions are about the sampling distribution, or the distribution of the sample means. Means the same thing. So be careful here. They give you mu and sigma, and then they tell you n. If I were giving you this on a quiz, I would say you intend to measure a random sample of 51 trees. I wouldn't say n equals 51. Not quite that nice, I suppose. And then maybe I'd ask you for the center of the distribution. The center of the sampling distribution, mu sub x bar is the fancy symbol for that. And it's always just equal to mu, so your answer here will be 235. And then sigma sub x bar, the standard deviation of the distribution of the sample means, it's kind of a mouthful to say, so sometimes it's just called the standard error, is what you're supposed to figure out. That's sigma sub x bar. That's not the same as sigma. That's sigma divided by the square root of n. So you don't actually calculate any probabilities here. You don't use inverse norm or normal CDF. You kind of just set up the problem. And you'll do that for several of these. I think like half the homework problems are just talking about mu sub x bar, sigma sub x bar, and the shape of the distribution. Because those are pretty important topics in 4.1, understanding those three things. Understanding the difference between the parent distribution and the sampling distribution. Question 2, more of the same. They tell you about the parent distribution. They ask you about the sampling distribution. It's very similar. They ask for mu sub x bar and sigma sub x bar. Question 3, back to newts for whatever reason. X represents the full length of 1 newt, right? So not of the average of 89 newts, just of 1 newt. All this information up here is parent distribution stuff, just talking about a single newt. Tells me the average, so here's mu right here, not mu sub x bar, but mu. Here's sigma right here, not sigma sub x bar, but sigma. And what they're telling us is that our sample size is 89. We're supposed to draw the picture. Well, the picture is going to end up being approximately normal. And you're like, how do you know it's approximately normal? How do you know the length of a newt is approximately normal? Oh, I guess it does say it in this problem. In this problem, they tell me the parent distribution is normal, so it doesn't even matter what n is. I'd be fine if n were 9. It doesn't matter. But because they told me the parent distribution is normal, I get that the sampling distribution is normal for free. But even if they didn't tell me the parent distribution was normal, I'd be good because n is greater than or equal to 30. So I'd be able to draw this bell curve down here when I draw my sampling distribution. And when I'm drawing the bell curve, I need to know the center and the spread of this bell curve, of the sampling distribution. Mu sub x bar, that's just the same as mu. Sigma sub x bar, that's sigma divided by the square root of n. Something I don't ask you to do that this problem does is to put the little hash marks down at the bottom here. Right? So I guess the idea here is to show you that mu sub x bar is really what goes in the middle, and sigma sub x bar, not sigma, not 5.7, but the number you get in this box is what you're going to be counting up and down by when you figure out these answers here. Note that they want these two things to 3 decimal places and the boxes to 2 decimal places. So I type those all in. This box is 2 standard deviations above the mean. 2, I should say, standard errors above the mean. 2 of these above this. Still no inverse normal CDF. The first 3 problems, half of them, just setting stuff up. Here's the first one where you use either inverse normal or normal CDF. Maybe I'll let you figure out which you're using here. But I do want to give you a hint here. There's 2 questions. We're talking about the length of pregnancies in a small rural village. All right, whatever. They're normally distributed, apparently. And the mean is 261 days. That's mu right there. And the standard deviation is 12 days. That's sigma. And this question, this first question here, is not a chapter 4 question. The second one's great. This belongs perfectly right here. Let's skip this first one, read the second one, then we'll go back to the first one. If you were to draw samples of size 35, now we're talking about a sampling distribution. I want to know about the average of 35 women, the length of the pregnancy of, the average length of the pregnancy of these 35 women. I want to know the range that those fall into. Sure, that's a 4.1 question. This is, I'm looking for the middle 95%. I'm not trying to find the area under the curve. I'm told the area under the curve. Maybe you can draw your picture to figure out where the 95% is, figure out how much area is to the left of the 2 points you're looking for. The point is 4.1 here, great question. Looks a lot like one of the examples I did in the sampling distribution examples video. It's a great one to practice on. This one's not. This one, go back to chapter 3 if you need help with this one. This is a 3.1 inverse norm. I wasn't even going to tell you that's inverse norm. It is inverse norm question. In what range would you expect to find the middle 95% of pregnancies? Not talking about averages of 35, but just of individual pregnancies. I don't need a mu sub x bar nor a sigma sub x bar. This is a chapter 3 question. This is a chapter 4 question. And that'll happen a lot in this section where they mix chapter 3 questions in there because they want you, the student, to be able to recognize a chapter 4 question even if it's chapter 4 because you're in the chapter 4 homework. All right, so they throw in some that don't belong. Anyways, question 5. Slices of pizza for a certain brand have a mass that is approximately normally distributed. So there we go, the parent distribution is normal. So I don't even care what the sample size is. With the mean of 67 grams and a standard deviation of 2 grams. So they're giving me mu and sigma here. For sample sizes of 16 pizza slices. Sounds a lot like a sampling distribution question. What is the standard deviation for the sampling distribution of the sample mean? That's a mouthful. They're asking you for the standard error. They're asking you for sigma sub x bar. What is the probability? Stop reading right there. Might be able to discern which calculator function you're going to be using, inverse norm or normal CDF, just on that. What is the probability of finding a random slice? So just one slice here. It's talking about a single slice that has a mass less than this. Contrast that with what is the probability that the average of 16 slices is less than that weight. Maybe one of these is really from chapter 3 and one of these is from chapter 4. Let's take a look at the two of those. And then a part D here. What sample mean for a sample of size 16, so again we're talking about the sampling distribution here, would represent the bottom 15%. If I had 16 slices of pizza and I calculated the average weight of those 16 slices of pizza, how light would it have to be so that it was lighter than 85% of observations? Only 15, not observations, of averages. Only 15% of averages way less than my average. It's a sampling distribution question. We're told the area. Maybe you can figure out the calculator function that you'd use. Finally, question 6. This one's tricky. First one's fine. What is the probability that the area covered by one single can of spray paint, think chapter 3, is more than 27 square feet? That's fine. B and C, I don't know. They're clever, I guess. If you can understand what's going on here, great. We talk about it a lot more when we have a face-to-face class. In an online class, maybe you can view the two of these as extra credit. If you want to answer them, what's going on is they tell you that how much you can cover with a single can of spray paint is normally distributed. This is parent distribution. The mean, mu, is 25. The standard deviation, sigma, is 3. They ask you a chapter 3 question up here. Fine, that's easy enough. And then down here, they ask me, what is the probability that you can cover, and I know I skipped part B, I'll go back to it. What is the probability that you can cover 540 square feet using 20 cans of spray paint? This means the exact same thing as what is the probability that the average amount that you cover in a sample of 20 cans is more than 27 square feet. Ooh, where 27 come from? If you want 20 cans to cover 540 square feet, each of the 20 cans on average will have to cover 1/20th of 540 square feet. I could tell you that 1/20th of 540 is 27. So if each one individually, on average, is doing 27 or more, then all of them together will do 540 or more. The reason I do that translation for you is because the way it's written doesn't fit into our mold of how these problems look. Right? What is the probability that 20 cans cover more than 540 square feet? You don't know how to answer that. But if you can translate this to, what is the probability that the average of 20 cans will be more than 27 square feet? I think you can answer this question. And you might be like, all right, I think I kind of get it, although I don't know where you got that 27 square feet, or at least I, the student, wouldn't have come up with that 27 on my own. That's what B is all about. B is just trying to understand where that 27 came from. The answer to B is 27. If you want to cover 540 square feet using 20 cans, on average, how many square feet must each can be able to cover? We'll take 540 and divide it by 20. You'll get 27. That's the number that goes right here. This has nothing to do with inverse norm or normal CDF or anything. It's just the number 27. The only reason they ask it is to set up question C. So that's the idea with this last problem. If you can get anything out of it, great. If you can't, don't worry about it a whole lot. If you can get the rest of them right, and part A here, maybe you can call that good on this assignment. That's all I got.